Hello everyone, and welcome to this new video tutorial for Maverick Render. In this video we will go through the new features introduced in the most recent release of Maverick, especially our powerful scatter system. Let's begin with the new primitive object, with which you can procedurally create simple geometry shapes. This multi-purpose primitive comes handy to dress scenes. Of the different shapes the primitive object can adopt, let's choose a plane and set its dimensions. Next we will create a standard material and apply it to the plane, since primitives are material-less by default. This plane will support our tour through the key feature of our latest release, geometry scattering. Scatter is an object modifier that will allow us to massively instantiate one or more source objects on top of a base object. Scatter can be used to easily generate geometry structures that would otherwise be impractical or too memory-consuming. Let's see how. From the modifiers drop-down list you can create a scatter node. We must drop this newly created node on the object that will act as the base, which we can do in the Scene Explorer or in the IPR. In the Objects library you will find a new section for scatter. There you will find the Sources folder, with a convenient collection of small scatter source geometries. Let's add a cube to the scene. It is key that you are aware of the real dimensions of your base and source objects, because the required density and the number of instances generated will directly depend on those. Our little cube has a 1 cm side, for example. From the Source 1 plug in the Scatter modifier we will select the cube as a source. We have introduced a small usability improvement in this release, so you can choose between an icons or names list in this dialog. The scattered instances are generated automatically. Let's go through all the parameters in the Scatter modifier. First we find the count of instances. We may set an explicit total count and see what the result is. Or alternatively we may specify the number of instances per square centimeter. This is the recommended choice if you want a scatter modifier to work the same no matter the size of the base object you apply it on. This is the reason why being aware of real dimensions of base and source objects is crucial. Next we will enable the collision detection system. Once activated we will see how the sources no longer overlap. We may then keep increasing the total count of instance attempts to crowd the distribution a bit more. With the spacing parameter we may cram in or space out neighboring instances. Collision detection is somewhat limited compared to a full rigid body physics simulation in the sense that the resulting distribution is not a perfectly tight fit. However, it keeps intersections under control and produces dense distributions with a very reasonable memory usage. Let's add a second source. From the library we drop a cylinder on the IPR. In the Scatter modifier we click on the Source 2 plug and choose the cylinder. The scattering system will automatically shuffle the cube and the cylinder over the base object. Let's scale the source cylinder to see what happens to the scattered geometry. In order for scatter to catch up with the scaled geometry, we must either reset scale or reset X-form. Rest X-form centers the X-form at the center of the cylinder, which may not be what we want. We may use the pivot options in the Move panel to place the X-form at the base, for example. The Randomize attribute changes the random instance generation seed. An interesting feature is the per source frequency. By default all sources are evenly distributed, but we may change their relative frequency so give more prevalence to one source over the others. Let's introduce now the concept of density maps. Let's click on one of these plugs and pick a map node of our liking, such as checker. With the Show in Viewport option of the map you may preview how it is textured on the base object. Scatter will now place instances only in the white parts of the density map, leaving the black parts empty. For the sake of rendering efficiency, Any changes you make in the internal attributes of a density map require that you update geometry from the toolbar. Conveniently, applying an UV map modifier to the base will also affect the density map. You may move the UV map around and update geometry to make the scatter modifier catch up with your changes. Let's disconnect the master density map and use a per-source density map. Each source may use its own independent density map. Let's enable these density controls here and drop some of the new density maps that we have added to the shading library. On drop, Maverick will ask where we want the maps to be connected. We will choose density map 1 in this case. In order to better see the effect, let's disable collision detection and source 2. As you can see, source 1 is being scattered only in the white areas of the density map. Next, let's make the cylinder, source 2, be scattered in the areas where source 1 is not present. To do this, we will drop the scatter node in the nodal editor. We will add a correction map from the special maps category. We will connect the density map to the correction node and then to density map 2. Now both sources are scattered in the white parts of the map. But if we use invert out in the correction node and update geometry from the toolbar, we will see how the cylinders show up only in the black areas. Let's move on to the X-form randomization attributes in the scatter modifier. They all work similarly. Each attribute features a randomization range, given by a minimum and a maximum value. Let's play with Translate Z. Instances are now ranging between the minimum and maximum Z values we set. In rotation, we may randomize for axes X and Y to produce a much more chaotic distribution. We may do something similar with the scale ranges. Each attribute can be controlled with a texture as well. Let's reset these attributes to their default values by right-clicking on the arrows of each spinbox. Let's now drop a library map on the scatter node and choose Global Scale Map. Black in the map means minimum scale, with the grayscale in between reaching white meaning maximum scale. We may amplify the effect of the map by editing the numerical values. Let's disconnect this map and apply another on the Z-axis scale. By editing the numerical values, we are defining the range between which black and white in the map operate. This way you can create interesting variations in your scattered geometry. Finally, let's see what the Align to Normal feature does. Let's rotate our base object and the scattered geometry along with it. Align to Normal forces verticality along the Z-axis. Let's dive deep now in the subject of material configuration for scattered geometry. If we use pre-made scatter sources from the Maverick library, we will see how their color is subtly randomized by default. You may figure out how this works by clicking the source in the attribute editor, or from the Materials Scene Explorer. These sources feature a color map in the diffuse map slot, which is used to produce said randomization. We may randomize in hue, saturation, or lightness. Let's see how to achieve something similar starting from scratch. Let's create a standard material and drop it on our source. In the Diffuse Color Map plug, we will pick a color map so the hue, saturation and lightness randomization attributes are available. Let's learn about more options. We will scatter some geometry in this scene. By keeping the base object selected and creating a scatter modifier, the newly created modifier gets automatically connected to the base object without having to drop it explicitly ourselves. Let's group the parts of the teapot in a group container by selecting the teapot parts and using the corresponding toolbar button, or with the keyboard shortcut Shift-G. We may rename the group for better identification. Scatter supports group sources as well as individual object sources. As we can see, the group's pivot is placed at its center. Let's select it and send it to the bottom, and then update geometry for scatter to pick up the change. Let's fine-tune the scatter modifier a bit to trim some instances out. Let's now drop a wood material from the library on the T-opt in the Scene Explorer. Say that we want to randomize the wood color a bit. To this end, we will send the material to the nodal editor by dropping it, or with the keyboard shortcut N. We will use a color map that will bridge between the original diffuse map and the material. Once plugged, we may play with the randomization attributes. Next, we will see how to randomize, not just material textures and colors, but materials themselves. Let's start by creating a switch material. Let's plug our previous material to the first slot in the switch, and apply the switch itself to the teapot. Then let's enable the second slot in the switch and plug a new material from the library using the nodal editor. Scatter will now shuffle the materials across the instances. Let's do the same with a third material. A little trick you can use to give more prevalence to one material over the others is to connect the material to the switch more than once. Let's now explore an advanced scatter and materials example. Let's create a scatter modifier and apply it to our plane primitive. Let's add one of the wall sources featured in the new Maverick library. Let's plug it to the first source in the scatter node and adjust the count and scale until we reach a population density we're happy with. Say that we want our scattered instances to grow colored from a texture pattern at the base object. To this end, we will drop the color pattern texture to the diffuse color map of the source's material. As expected, the texture is applied individually to each source as expected. But this is not what we want. If we navigate to the options of the texture, we will find a new mode called Instance UVs that will pick the color of the texture at the root of each instance. The effect of this option becomes obvious right away. Each instance inherits the color of the applied texture at the contacting point with the base. Keep in mind that you will need to update geometry for changes in UV mapping to have effect. We may also add small per instance color variations on top of the overall texture. All we need to do is use a colorgan map with the texture and play with the randomization attributes. Finally, let's disable the scatter we just created and try with a pre-made one from the library. Let's drop rocks from the library on our plane primitive to get a rocky scatter automatically. Say that we want our rocks to inherit the textured color from the previous example. To achieve this, we will drop the material of the sources in the nodal editor. We will add a composite node and plug it to the diffuse color map slot. In color 1 we will plug the rocks texture. In color 2 we will plug the color texture in Instance UVs mode. Keep in mind that in order to reveal the attributes of a node from the nodal editor, all you need to do is double-click the node. In the composite node we will switch over to multiply mode and adjust the overlay weight. As we will see, the rocks get tinted by the color texture. We will do the same with the 3 sources. This technique allows for very advanced results. We will use the UV map modifier we created earlier to slide the color texture across the scattered geometry. Let's now take a look at the library of pre-made scatters that is included in our latest release. These scatters work right away by just dropping them on your objects. Keep in mind that depending on the surface area of the target object, and the density of the scatter itself, some may take some seconds to generate. Once dropped, all the attributes are available for you to have fun with. Let's, for example, change the size and density of this one. The colored chunks in the counters panel provide a live report of the memory usage of Maverick. Our scatter system is based on instancing, which allows for a massive number of instances with a very modest memory footprint. However, instances still require their positions, orientations and ray tracing structures to sit in memory, so please be aware of real dimensions and densities when experimenting with scatter. Let's turn off the scatters we've been adding and drop new ones. The Grains folder features tiny particles to decorate your scenes. Again, please be aware that tiny particles and large surfaces are a combination to be careful with memory-wise. Let's do a creative setup with floating particles. Let's add a plane primitive in the scene. Let's drop a particle scatter on top of it. Scatter goes upwards, so we will rotate the primitive to make the particles go down. We will hide the plane primitive away from the scene and enable depth of field for a more photographic look. We may keep playfully dropping scatters. The possibilities to enrich scenes are endless, and we can't wait to see what you can do with all these new features in your hands. To wrap this tutorial up, we will learn how to save scatters so we can reuse them in other scenes. Once we have a scatter of our liking, we make right-click on it to reveal its context menu and then select Save to Library. Our scatter will be saved in the My Scatters directory in the library. All you need to do is drop the scatter file on any other scene. We hope you that have enjoyed this journey through our new scatter system. In the description of this video you will find an index to browse through the topics of this tutorial. This is all for now. See you in the next video. Have fun rendering with Maverick.